this video, we are going to do second experiment in the clipper circuits. So that is a negative peak clipper. So the difference between positive peak clipper and negative peak clipper is in the positive peak clipper, any voltages above that set value will be positive peak will be clipped here. So now we'll clip negative portion of the input. So the changes you have to make is same circuit you already simulated, no? In that you reverse the diode as well as reverse the power supply. Okay, you change the direction of the diode and change the direction of the power supply. So the same circuit now works as negative peak clipper. So in the transfer characteristics also it will come like this in the negative cycle. Now diode is reversed, reference voltage is also reversed, so output is limited to -2 volts. So this is diode is connected opposite now, but we connected the CRO plus here minus here only. So we are measuring output plus here minus here. Here we got diode positive here, negative here. So here negative, this is positive. So minus zero point 0.6 is there. So here you have to add minus 1.4. So for minus 1.4, negative is this side. Okay, negative is this side. So minus 4, you just type 1.4. Okay, if I write top positive, down negative, then you have to type the value as minus 1.4. Otherwise, minus is there, plus is there. Just change the value to 1.4 so that this is zero point 0.6 and this is 1.4. Both are negative, positive, negative, positive. So we are adding output, we are finding output voltage across this. So any voltages less than minus 2 volts, the diode becomes forward bias and acts as a short circuit. So at that time, output will be equal to sum of these two voltages. Okay, that is minus 1.4 minus zero point 0.6. Output is limited to minus 2 volts. I will tell you once again. For any input voltages less than minus 2 volts, okay, minus 2 volts how means VD plus VA reference. Okay, reference is negative voltage, this is also negative. So any voltage less than V cut in voltage and reference voltage, then diode becomes forward bias because diode connected in opposite. That's why in the negative of cycle diode becomes forward bias. Okay. Now at that time once it becomes short circuit, now there is a two battery sources connected in parallel across the output. So it is always equal to DC voltage of this VD minus zero point 0.6 minus 1.4. It is going to get, it is limit, it is horizontal. Okay, for other voltages, diode acts as open circuit. When the diode acts as open circuit, output is same as input. So output follows input. So in the positive of cycle also here, for any voltages less than 2 volts, diode is open circuit. Diode is open circuit. So output follows input. For input voltages greater than this voltage, that is 2 volts, diode is short circuit, acts as a voltage source of 0.6 plus this. So output voltage is sum of these two voltages. Okay, now let us change the previous circuit. This is the first circuit. So how to do this one? You can refer my first video, positive clipper, and you can check the output. Now I'm going to explain how to change this circuit. How to change this circuit to negative peak clipper. So click on the diode. Okay, click on the diode, or here you can see one red color wire. So the small wire you can see delete it. Here also you can see some red color wire. This you select and delete it. This also you have to select and delete it. Now I want to reverse the diode. I want to reverse the diode. I want to reverse the power supply. Click on this. So press Ctrl R. It is changed. Click on this. Press Ctrl R. Suppose if you want to have both the first file as well as second file, what you can do is go to file, save as another file name. In that modified file name, you can do the modification. What otherwise, one more thing, what you can do is copy entire circuit. Okay, like this, you copy entire circuit, you copy Control C, copy the circuit, and you can place here. You can copy and place, it will come here one more time. I opened so many applications, that's why it is little bit slow. Actually, it will come fast only. If it is running, it will not come. Yeah, now it came. You can copy and you can drag, click up and down arrow mark. I am clicking the up arrow mark, so it is moving left. You can going up, down. You can move wherever you want. You can place like this. Okay. So no need to once again pick and place the component. First time if you want to do, you refer my positive peak clippers video. This is just I want to save the time. I'm just changing how to reverse the diode of the diode. So for that, what I did, I just deleted this red color line and this red color. Now, so that if I rotate now, other connection should not affect. That's why before rotating, I removed the connected part. Now I rotated two times. So join this, join this. Okay. Just let me connect as it is. This is not required actually. Simply if it is open now, it will show some errors. That's why this is positive peak clipper circuit diagram, which we did in the first video. Now I am actually explaining negative peak clipper. Negative peak clipper. The circuit diagram is this. Negative peak clipper. The circuit diagram is this portion. Okay. Or now let me explain once again how we place this one function generator. In the right side, first block is second block is function generator. After that, set this value to sinusoidal waveform, 1 kilowatt signal, 5 volts peak. Okay, positive 5 volts it will come, negative 5 volts it will come. Okay, and you place it one place assist place component. Okay, those who don't see the first video, go to place component. In the basic resistor is there. So group you have to change it to basic so that you'll see all the basic components. The resistor is there, capacitor indicates the resistor. You can select the 3.3K and click OK, it will come. Again, go to place component, go to diode and place diode also. Place component, basics, and in the basic, diode is there. Okay, in the groups, you select diode, and in the diode, you select 1N4007G. After that, DC power source, go to sources, select power sources. In the right side, you select DC power source and click OK. And for rotation, you have to press Ctrl R two times. Okay, for every Ctrl R, it will rotate by 90 degree. Okay, so after that, you have to place function generator, and ground is also available in power sources. Okay, power source group. And in the oscilloscope, so here we have oscilloscope right side. Okay, if you want, you can place. Otherwise, press escape, it will go. So now here, now the output is actually it is negative peak will be clipped. You have to press the run button here, double click on the oscilloscope. Now you can see now this is actually transfer characteristics coming immediately. If you don't want transfer characteristics, you type Y versus T. Y means output versus with respect to time. T means time. Okay. So if I click auto, it's continuously running. So if you want to stop the waveform, click on single. If you want to reverse the background, click on this. If you want to change the color of waveforms, and you can change this to output to any value you want. So if you want to modify this, stop the program, right click, okay, go to segment color, change that color to any color you want. Output is A, channel A. I set the color to blue color. Input is green color. This is input. From plus I connected to this. See the left side of R1, it is connected to the input. So I use the channel B to see the output, what is the waveform it's coming from the input. I connected here. I right click this. I change the color to segment color to my own color. So any color you can select. Okay. You can select any color. Any color you can select. Okay. Now run this. By default, it will show Y versus T, output versus T. If it is single, after single plot, output will stop. If I want continuous, say I'm telling now only, if the frequency is 1 kilohertz, you can observe single. If the frequency is 50 hertz and all, you cannot stop at single, you have to click auto only. So we set the value to 50 hertz. So if I click single, waveform will stop. What is the output here? So input observe here. Input is green color. So two channels are there. Observe here what in which channel you are connected. Channel A connected to this output. This is output side. This is input side. Input is connected to channel B. Output is connected to channel A. So if I want to see only output, channel B I have to ground. Channel B I will make it 0. So this is only output. And output is channel A. This should be DC. If I connect 0, no output is coming. If I connect AC, you are not going to get 2 volts. It is automatically adjust area of this will be equal to area of this. So output should be DC. So that it is fixed. Now it is one box. From here to here it is one box. So what is the per division? How many volts? You can see here 2 volts per division. 2 volts per division. So one division into 2. So the negative voltage is clipped at 2 volts. All the voltages, input voltages, you can see input also. This portion, all the voltages less than 2 volts are removed, they are clipped off, and only voltages above minus 2 volts are coming here. So this is called as negative peak clippers. So negative this much peak is removed here also. Increase input voltage any value, this will not increase. This is always equal to this. If I increase the value of this, positive side it will increase, but negative side it is clipped off. All the voltages are limited to minus 2 volts. So this is the meaning of clipper circuit. So this is application wherever you want to restrict the input voltage. For example, some circuit requires minus 2. Okay, you cannot give less than minus 2. That time you can make use of this. Okay, so any voltages coming less than that we can remove before enter into the circuit. Okay, so this is negative P clipper. So the third experiment I will explain in the next video where we are going to clip both side.